Hi. Now, we're given that sine 3 theta in the first part is identical to 3 sine theta minus 4 sine cube theta, and we're now asked to hence solve this equation, 8 sine cube theta minus 6 sine theta plus 1 equals 0, for theta between 0 and pi upon 3. So I'm kind of looking for a connection between this equation and what we've got up here. And what I notice is that these first two terms, okay, are double these two terms up here. If I doubled the 4 sine cube theta, I'm going to get an 8 sine cube theta, and if I double the 3 sine theta, I'm going to get the 6 sine theta. Only the signs are different. This is a plus, whereas we've got a minus here. So this gives me an idea to subtract 8 sine cube theta and add 6 sine theta to both sides of this equation. So if we start by doing that, we're going to therefore have that 1 equals 6 sine theta minus the 8 sine cube theta. Now if I pull out a common factor of 2 here on the right hand side, we're going to have 1 equals 2 lots of 3 sine theta minus 4 sine cube theta. And as you can see, this part here, 3 sine theta minus 4 sine cube theta, is what we have up here, and it's identical to sine 3 theta. So I can therefore say that 1 must be equal to 2 lots of sine 3 theta. Now this has given me a very simple trig equation now. All I've got to do is divide both sides by 2, and that gives me a half equals sine 3 theta, or basically that sine 3 theta equals a half. Now that I have that, I can find out what 3 theta is by taking the inverse sine of both sides. So 3 theta equals the inverse sine of a half. Now it says give your answers in terms of pi, so we'd expect the inverse sine of a half to be a very straightforward answer. And indeed it is. If you're working in degrees mode, the inverse sine of a half is 30 degrees. And 30 degrees in radians is pi over 6. Pi, remember, radians represents 180 degrees, so 180 degrees divided by 6 is 30 degrees. So pi over 6 for this answer. So we'll have 3 theta equals pi over 6 radians. But there's more than this, okay? You can find the other solutions either by drawing a graph of sine x, or you could use the quadrant method, which is the way I prefer to go. And what we're going to have is this line represents theta equaling 0, and this would be 90 degrees, or pi upon 2 radians, pi radians, and 3 pi upon 2 radians. And we're looking for where sine is a positive value, and sine is positive in the first quadrant and in the second quadrant. And always marking these two angles as being exactly the same to the horizontal. And what we have got is that this is a possible 3 theta, and we've also got from here round to here is also another possible 3 theta. If you're unsure of the quadrant diagram, just go on my website and you'll see tutorials on the quadrant diagram. So 3 theta, this one here, is a pi upon 6. So this angle in here is pi upon 6 radians. That means this one over here is also pi upon 6. So for this green 3 theta, I just need to have pi radians take away pi upon 6. That's going to be 5 pi upon 6. So 5 pi upon 6 is another angle, a possible angle for 3 theta. It's that green one there. So to get theta, all I need to do now is just divide each of these by 3. So therefore we end up with theta equaling pi over 18 and 5 pi over 18, and both of those are radians. Okay, it's the units, and there's our answer. Okay.